This session is going to be about SharePoint 2013. And you could kind of take it back to SharePoint 2010 performance. So some ideas about how to get your farm to perform well. And then the second half will be showing you how to run some testing. And this was primarily written for IT pros. So administrators, IT pros. However, if you're a developer, you'll still get value out of this, I hope. So I call it Tweaking SharePoint 2013. My name is Ben Curry. I am from Manchester, if you can tell by my accent. Just kidding. I am from Alabama, so deep U.S. I live in Huntsville. It's where Missile Command and Space Flight Center is in Huntsville. And that's where Summit 7 is based out of. And security background, scuba diver, and a scuba instructor is what I do for fun when I'm not doing SharePoint or wrangling two kids I have. There's my Twitter. It's Curry Ben. You can check out my blog. I blog occasionally, but not a terrible amount. Here's our agenda. First, we're going to look at some general guidelines for scaling and performance. We're going to follow that by scaling web applications, scaling service applications, and that's about half of our session. The last half will be web and load testing, and most of you already have the tools and licenses to do this testing, so you don't need to go buy a third-party product. I think that's the good news. And we have more than 10 people in the last session of the conference, so that's impressive. So thank you very much for coming. Who's not going to laugh today at all, no matter what? Okay, thanks. Do you have this today? God, I wish I had that. Do you recognize this? New Ferrari. Some people actually have this Ferrari. If you an analogy to their SharePoint, I've seen a 20 SharePoint server farm that has everything turned on and has been brilliantly architected, and it's fast, it's uber cool and very sexy. Most people don't have that for two reasons. They have neither the expertise or experience or the money. I know it comes back to the money. It's always about pounds or euros or yen or something, isn't it? Because to have a Ferrari, see, the Ferrari meets every one of my requirements. See, I did correct discovery. I went through all my requirements. It's fast, lots of horsepower, it's comfortable, it has leather. It met all of my requirements, and there was only one problem with it. I couldn't afford it. So today we're going to talk about the compromise. I think a lot of people actually had this. This is actually from Alabama. It's a four-wheel drive Yugo. Now, if that's not redneck, I don't know what is. But this is what this guy could afford, right? So we try to live within our constraints of budget. Budget's real world. But let me warn you, and we see this happen a lot. If you try to make a Ferrari out of your Yugo, this is what likely is going to happen. It is going to burn to the ground. We've seen this, right? I'm going to say, well, management says, well, we have to put 10,000 users on these two web front ends that have 4 gig of RAM each, and they have 40 gigabyte system drives. Just make it work, or you're fired. So we go make it work, and what happens? They catch on fire, they burn to the ground, they don't work, and then whose fault is it? Still our fault, even though we told them it wasn't enough juice. You can't make a Ferrari out of a Yugo. The single best resource for capacity planning and boundary is right there on TechNet. If you want to learn SharePoint 2013, I promise you this. If you read this and all the links off of this page, it'll take you about 85 hours if you don't do any deep dives. I've done it once. You'll learn more about SharePoint 2013 than any other resource. In my opinion, there's two ways to really learn the depth of a product. In the 90s, I owned an internet security company. I believe either IT security, learn the security of software, or learn capacity planning. Either one of those helps you really learn the inside of software. So even if you're never going to scale really large, understanding how to scale it really helps you understand the architecture. By reading this, it'll give you a three-dimensional view of how this product works. Some big changes in 2013, especially when it comes to performance and scaling. I think number one performance hit we're seeing is that the fast is now baked into the farm. SharePoint 2010 search is gone. Search scopes are gone. Query servers are gone. Basically, we have now content processors. We have an index and query component. We have analytics. So we have big changes around search. And what we're seeing early on in 2013 implementations is that the search architecture is driving much of the farm architecture. Most people are not getting away with 2 search servers. Most are actually requiring 4 search servers or 4 application servers. So really the new standard or the minimum's gone from kind of this 4 server farm where I had 2 webs and 2 apps to really a 6 server farm, and that's because of the search requirements. Second thing you'll notice is workflow has been moved off of farm. It's now, they still support the OWS timer-based workflow like we had in 2010 and 2007. Did any of us actually like that workflow? No, because about 1 in every 200 workflows just went into a black hole and we don't know where they went to. Part of the way we resolve that is by putting in an off-farm workflow. It's called the workflow management. And you actually have to build another server farm just for workflow. It'll install a workflow manager and a service bus. We then wire that up to the web front ends. The great thing about this is, though, this is going to give us scale. Now, you have to ask yourself, do I put this on my application servers in my farm, or do I add 2 more servers? Most of us, real world, we're putting it on 2 servers that are already on our farm. We're not adding 2 more servers because people are going to look at your IT, your SharePoint farm, and say, I need 8 servers, 12 servers, and they're going to say no. The last is Office Web Apps is now a dedicated farm, and here's the kicker. It cannot be hosted on a SharePoint server. You cannot put this on a farm server. You must have dedicated hardware or dedicated virtual machines for Office Web Apps. Big change. Not a service app. Some of the boundaries and limits. When we start to look at capacity and performance planning, I'm going to give you a quick hit list here. The first thing you want to look at is go to the Microsoft site. It's not a hard read. This is 1 page of all the boundaries and limits. Content databases, lists and libraries. Look and see, am I breaking any rules, any common sense rules? Second is define your targets. We hear so often in business, and they'll say, well, we want a fast website. Well, what does a fast website mean to you? Does that mean the page comes up instantly or 1 second, but then my BI components come up in the background, say, over 3 seconds? Or do you mean the whole page needs to be up in 2 seconds? Is it the same for my local people as it is for the ones in Paris and the ones in Belgium? What is your target? And then test to those targets. Really, in 2013, there's no reason for us to be guessing what our performance is at any given time. I would say create the logical architecture first. Your service applications, so things like search, user profiles, you were interested in Spencer's, access services, Visio services, project server. Look at all of the services and then all of your web applications, your application pools, how many site collections, how many managed paths. Once you know that, that will help you define your physical architecture. Building out a physical architecture before you understand the services and content you're going to service, it's kind of backwards. So if at all possible, create the logical architecture first and then move into the physical architecture. Test and validate. We break every server farm we build. I'm with Summit 7 Consulting out of the US, and we break every server farm we build. Kind of cool, right? It's one of the favorite parts of my job. When we break a server farm, we know its limits. The only way, in my humble opinion, you know the limits of a server farm is to break it. Break the services, break the web apps, break the app pools, know where it breaks. We then back off 20%. So about 80% of wherever those counters were that it broke, we find across the board, that's where we're looking for and getting alerts. I'll say SCOM or some other tool. Beware though, and I'm going to show you how to do some of this testing. As you fix issues, let's say that we fix an application pool issue that allows 200 concurrent users at this point, you may open up a new fracture and going into SQL. This thing kind of moves around. So as you start fixing places in the server farm, you'll open up a new bottleneck, and at some point you'll get your performance you're looking for. But just know you're not going to run performance tests and everything's going to be fine. You're going to run a performance test, and you're going to say, I've got an app pool problem. You're going to fix it. And then as soon as you run it, you say, I've got a service app database problem. I'm going to fix it. And then I've got a SQL server. I've got a duplex issue on the switch, something really common, for example. Log and monitor. And it's really important in 2013, even more so than 2010, is that we adjust our architecture as needed. It's really easy to change the service machine instances of where things live in the farm. When we first install a server farm, we check every 30 days, we do a health check for 6 months. So what we do is every 30 days, we look at the CPU utilization for all of our service applications, all of our web applications. Usually, they're not completely level across the farm. We'll take that opportunity to take an outage and then balance them across the farm, because you don't really know exactly what all your users are going to leverage in the farm. So log and monitor, and don't be afraid. When you go to TechNet or MSDN, but mostly TechNet, really important to hear if you want to stay in support with Microsoft, there's 3 types of limits or boundaries. They have what they say boundaries, and those are static limits that they've hard-coded into the product that we cannot engineer past. Hard limits. 300 content databases for a web application, hard limit. You can't script 301, it fails. Thresholds, however, are configurable limits that can be exceeded to accommodate specific requirements. A really good example of this would be document upload. The default is what? 50 megabytes? You can go up to 2 gigabytes, can't you? So the maximum blob storage for SQL. That would be a threshold. But that 2 gigabyte upper limit would be a boundary, wouldn't it? It would be the most you can technically hard-coded limit is 2 gigabytes for that blob into SQL. And then there's supported limits. And this is the one that gets a lot of people in trouble, because you can go past it. A configurable limit, for example, they still recommend somewhere between 2 and 400 gigabyte content databases. But you can go to 4 terabytes. That's a pretty good sized database. They recommend doing it for archiving. We do it for like large medical, like hospital systems. It's where we actually will do patient archives and patient records in SharePoint. But once you move to 4 terabytes, your SharePoint backup strategy must change. Your replication's going to have to change. Your disaster recovery plan has to change. Your database maintenance definitely has to change. How you store your blobs have to change. Now, can I get my blobs and my databases replicated somewhere else and make sure those stay synchronized? And I have that complication. So I think when we look at supported limits, those are the common sense for the average person. When we move beyond the supported limits is where we need to apply additional engineering in our application. I'm not going to read through all of these. I want to give you some ideas kind of some of the boundaries that Microsoft has put out. Things like content databases. It will do 300 per web app. I'm not saying it should do 300 per web app. I don't like to get over about 100 content databases. It slows down administration. If you get over 100 content databases, it's better off to manage your site collections via PowerShell. You still have 5 zones, 20 managed paths, 10 application pools per server. Big change here, 10 application pools is what's supported. You can go beyond it now with extra engineering. It was limited by hardware. In 2010, it was 10 no matter what, and you wouldn't get supported. Now it's 10, and if you go beyond 10, as long as you can show Microsoft you have enough hardware, CPU and RAM, they will allow you to go beyond 10 app pools now. And so that is one big change here I wanted to point out. 20 web apps per farm. Microsoft recommends 1 per farm in 2013. I don't work for Microsoft, but they really think you can do everything with a single web app in 2013. I would say on average we're seeing 3 or 4. But because of the way hostname site collections work wonderfully, we're not seeing 10 web apps anymore, we're seeing 2 or 3 web applications. And that's usually for things like web app policies and zones, and policies on zones. Content databases, it's still 200 gigabytes, but you'll see 4 terabytes, and that's with restrictions. What I think is really interesting is if you move over a 200 gigabyte disk, the minimum I/O is 0.25 IOPS per gigabyte. Okay, you got that? Which means if you're getting really big drives, you're going to need a lot of speed. So 2 IOPS per gigabyte is the recommendation on content databases. So if you're actually moving into large content databases, you're going to have large RAID arrays. And you probably, look, we still do some of this via direct attached storage. DAS isn't a dirty word. It's a cheap way to get some stuff and we can get availability. But either way, you're going to have a lot of speed on the back end. As your content databases get larger, you're going to need more disk. You can now, this is a real problem. You can only have 750,000 site collections per farm. They really tied our hands behind our back on this one. I don't know how to architect anymore. I don't know who hits this, maybe Office 365. Site collection size, they pulled the maximum, which is interesting. You can have 60 million items per site collection, which means you could have 2 full libraries, which is 30 million per library. Major versions, once again, we can only have 400,000 major versions in a library now. I don't know how we're going to engineer around that limitation. My humor is dry, by the way, if you couldn't tell. 2,000 subsites per view. Search boundaries, wow. There's a whole section on search. Just go read it for fun. But here, so let's apply some common sense. Let's take this. How many documents can I have in a document library? We said 30 million. Okay. What was the maximum blob size, theoretically? 2 gigabyte, right. Now, do you think it's smart to go to the maximum number and the maximum threshold? So we can do 30 million 2 gigabyte blobs in a single document library. Is that good or bad? I'll make it simple. That's bad, right? As you increase the upload size, you need to be smart. We need to be smart. We need to be decreasing how many items we're going to allow in that library. This is a logical concept I want you to take throughout the farm. Take content databases. We can have 300 content databases. The maximum size is 4 terabytes. Do you want 300 4 terabyte content databases on a web app? I don't, and I don't want to pay it, nor would I build it. So the recommendations of 300 is based on the recommendation of 200 gigabyte content databases. They're saying you can have 300 databases that are 200 gigabytes in size. So just remember this. Anytime you push on SharePoint on one side to get more performance or more capacity, you're affecting something else, the flip side. One of the best places when you're building your 2013 farm is to actually get the usage of the 2010 farm. Look at the transactions, the read, the writes, the Excel services, the BI, the performance point. What we found is over half the traffic isn't content. It's not documents. It's not Excel spreadsheets. It's not that cool PowerPoint for marketing. It's BI traffic. It's dashboards. It's line of business integration. It's Excel services. It's performance point. Power Pivot, as bad as that is to put in, we still see lots of Power Pivot. Sales guys love it, right? So think about the services. A lot of your traffic is actually services, things like operations. I'm going to go here and I'm going to say at the very bottom here, 4 nines is achievable, but most people can't afford it. Anybody here have to go to 4 nines as their uptime? Very good. We found that going from a 24-hour SLA to an 8-hour SLA, average at double the cost of the solution. That's a lot, isn't it? So 24 hours to 8. To go from 8 to 4, doubled it again. This was at NASA where we did this study. And from 8 to 4, doubled it, and from 4 to 2 hours, doubled it again. So it gets very expensive, very fast if you're trying to have really short SLAs. Really short SLAs is where we start to look at cloud solutions. That's where we start to see it cross and it's more reasonable. So let's talk about performance. I'm going to go through Web Architecture 101. Don't get up and leave. You probably know this. I want to make sure you know it, though. Web Application Architecture, it's an empty bucket with at least one site collection. That site collection completely lives inside a single content database. That site collection cannot span content databases in any way, shape, or form. So if you have a 1 terabyte site collection, you have at least a 1 terabyte content database. However, a content database can host multiple site collections. Make sense? Now, when we talk about performance off of this thing, we're talking, well, the way we get into site collections in the web app is through our web servers, so that application pool. So they're actually web servers serving up the data. That's where we're monitoring the web traffic. It's also where you'll see like your BI web parts churning on the web front end. If we're doing lots of read and write activity, however, we'll see it hit back on SQL Server and the content databases, especially also with service applications, things like search. What about service applications? How do we get these to speed up? Well, fairly straightforward, I think, and I'll show you this. Service applications can be serviced by multiple physical servers. Let's take Excel services. If I have 2 Excel services servers, I have 2 servers that can do the performance, and I have high availability. One crashes, it still works. let me give you the one-on-one on service application architecture to take home with you. This was mimicked off of the managed metadata. I believe it's, as far as I could tell, was roughly the only service app written to spec, for what it's worth. Just for fun, we created 3 web servers and 3 application servers. The very first thing we get is a service, what we call a service instance. The service instance means we installed the software. We then get a service machine instance. That means we turned it on. I don't know why TechNet made this look kind of harder than it is. But if you've installed SharePoint with all the bits, you have the service instance. It's the actual DLL executable web service. When I turn on the DLL executable, the web service, that's when I get a service machine instance. This service application will use at least one service machine instance. If you had a service application with no service machine instances, you would get nothing back. The more machines that I add into this application tier, if you will, theoretically, the faster my farm should be on that service application, the more availability. Now, here's something often overlooked. Service applications often have a database. How fast is that database? How fast is that disk? Search. Anybody know the minimum IOPS for a search database? It's 2,000 IOPS. Really? Ouch. So when we're doing our service applications, we have to look at every service application individually. It takes a while. I got 14 white papers I downloaded from TechNet for every service application and what the minimum specs are for drive and CPU. And you'll be really surprised at the amount of IOPS you'll need on the disk itself. Anyway, so we have the service application, and what we have is the web application on every web server. Let me phrase this a different way. Every server that's running the SharePoint Foundation web application service on server connects through a service application proxy to find out where the machine is that's processing that service. Excel services. So if I'm Johnny Joe end user and I'm running Excel services in the web app says I'm associated with Excel services. It goes down here and finds me a machine. This proxy is intelligent, though. One of the things about scaling, if that spreadsheet, for example, had already been cached, this proxy knows where it was cached. It won't process it again. It'll send you to the server that has it cached. This is 3rd generation. This started in 2007. It actually works pretty slick. So where do I see this at in the product? That's a brilliant question, you might ask. So let's take a look at it. So in here, I am in SharePoint 2013. Under System Settings, Manage Services on Server, what I'm looking at here are services. Now, we talked about service applications and service machine instances. Notice something, though, is, I don't know, claims to Windows token service. Is that a service machine instance of a service app? No. It's just a SharePoint Foundation service. But if you come over here to Excel calculation services, is that a service machine instance of a service application? Yes, it is. The way we distribute and grow a service application is by going up here in Central Admin and just simply turning them on. It's not really rocket science. A few exceptions, user profiles, search could be a little harder than that. But things like Excel services, Visio services, Access services, for the most part, we just turn them on and off. So this right here, where I say start and stop, and let me show you something here, just cool, because you got to have this. So if I were to go into App02, what I'm going to do in App02 is I'm going to go down here and find that actual Excel service. So under SharePoint Web Services, it should be the first one here. I can verify that by Content View. See where I have there. See where I'm at under SharePoint Web Services. Did you know, by the way, how many consultants are here? You know something really cool? Every single person's first Excel service app has 155D990059F. It's actually not random. I found that the other day. It makes it really easy to write scripts, though, for multiple customers. And guess what? The second Excel services is always the same. Isn't that weird? Non-random GUIDs. Anyway, don't get sidetracked, but I think that's kind of interesting. So if I go over here into App 2, and if I turn off Excel calculation services, what would you expect to happen to that web service? You expect it to be gone, right? So I'll refresh, timer job, it's gone. See how this thing's working? It's not rocket science under the hood. When I go into central admin and I turn on one of those instances, it actually copies out the web service here, it creates the endpoint. Now some of these, it creates a Windows Server service as well, things like user profile imports and search. Makes sense so far? We're all on the same page? Not black magic under the hood. We're turning stuff on and off. All right, very good. Just to give you an idea of search being in its own beast, I need to work out a laptop. I've been on my Surface so long now, I'm wanting to touch my screen all the time. And this is not a touch screen. This is a straight out of the box search architecture for 2013 in its simplest form. You got it? So if you're upgrading to 2013, if you don't understand search, this is the place you need to probably get some help. It is fast, upgraded, and baked into. This is a 2013 search, and I'm telling you, this is the simplest we could make it. You have 5 components running. I'll get to that in a second. Crawl components. It's going to be really hard on a 4-server farm. Just for fun, I showed you kind of how we do service distribution and the way our drawings. These are 4 different servers, and you can see all the different instances and services running on each computer. Most of our big ones are E-size drawings that show you boxes and all the service instances. They can get fairly complex. The better configuration management you have, the easier it's going to be to manage these. So why performance test at all? Well, to meet new farm, we build a new farm, we want to break it to no. What about, we've never had a power pivot in our farm before, and we drop 2 power pivots on and we create a BI app. Don't we want to know how well the BI app works? So for example, we'll create a web test and we'll test just that single BI app. Guys, third-party code can be just as bad as custom code. Stuff you go buy from a vendor. I'm sure all the vendors here, their code's brilliant, but I've downloaded code and bought code from people that was quite honestly horrid. So one of the things we like to do is drop that third-party code on a web page, test it, and make sure it's not complete crap, rubbish, whatever you guys call it here. So let's go in and take a look at this. Woo! So what I'm going to be using here today is Visual Studio Ultimate. Now, if you're an administrator, don't get scared. Visual Studio 2012 is for administrators. But you know, I really shouldn't have done that. Let me close it, because here's how we open it. We really want to right-click and run as administrator. Sorry, it's a bad joke, isn't it? See, we're administrators up in Visual Studio. Never mind. So what I'm going to do here, first thing I'm going to do is open a new project. So File, New, Project. Look, I know we're admins and we button click. It's perfect. Visual Studio 2012 is perfect for us because we get to click a lot of buttons. The great thing is watching a dev try to get through it and they can't. And so you have to help them in Visual Studio. That's where it's real fun. You know how many devs it takes to change a light bulb? Well, none. It's a hardware problem. They won't change it at all. So what we're looking here for is a project type called test. If you don't see test, that means you probably have Visual Studio Pro. You have the wrong version. Go out to MSDN, download Ultimate. Most medium-sized companies and larger, you'll have the Ultimate license. If you don't, it's like $1,200. There's worse things. And I'm going to give this the name of the Cool Kids in London. And I'm going to create a brand new project. One of the first things I'll do here after we create it is I'll kill the unit test. I'm not going to do any unit testing today. And I want to not break my application. That is not at all. So I did some update. There we go. So one of the first things we're going to do here is kill these. Because we're administrators, we don't need it. I promise. All right, so here's our solution, Cool Kids in London. Everybody with me so far? This is cool, easy. We're going to say right-click, add. We could just say new item, but what we're going to do instead is come up here and say right-click, new. It did not create the correct project. I've only demoed this like 38 times, so, I'm still getting used to it. Test project. Oh, because it's choosing that. I got a new default there, don't I? Where did that come from? Yeah. Rookies. I got a new book coming out. I probably wouldn't buy it. I did change publishers, by the way. The last 4 I wrote were Microsoft Press. The new ones with Sam's. More freedom to actually write the truth. If anybody works for Microsoft, I'll deny I said that, by the way. So I go to my new web test. Thank you, whoever that was up front. You're exactly right. And what we could do here is add a new test. Add. I am absolutely losing my mind today. I have never in my life missed this. I have changed something on my machine. Oh, no, it should be right here. What did I do? What's that? Here. Yeah, right here. It should be. I should be able to add. But see, it's not, oh, I see here, new item. It's because of the, you're right, it's because I'm 1024 by 768. I'm used to seeing it on the left-hand side. It's true. I can't help it, but it's true. You guys, come on, guys, you're no fun. Okay, I'm going to do a web test here. Oh, come on, you guys are, what's that? Yeah, you guys are killing me. So what I'm going to do here is just a web performance test. I'm going to say add. I actually knew all this. I'm just testing you guys to kind of feel you out for the rest of the session of where you guys need to be. Well, the great things here, make sure you have ActiveX turned on this client or it'll fail. The first thing I like to do is just pause. This is why I think it's great for administrators. I browse out to my web application, portal.contoso.com. I then click record, and I come over here and just hit refresh. So just basically a portal read. That's all I want to know. If this is everybody's homepage in your company, this is the first thing they do when they get to work every morning. And I stop, and this is going to go out, back to Visual Studio, write all the scripts for me, and it's just magic. Now, this alone can actually be useful because we can actually come back in and we can play this again, over and over again. Let me find my web test. It'll finish. Because a lot of times we see end users come in and they'll do something like drop a 2 megabyte file on the home page. And everybody will say, oh, our web server is really slow, and it's because we have huge images or we have a new third-party web part that's killing our services. So it's actually a decent way to test a single page. I'll show you here. So if I simply want to run this again, I will run test. Now what we're going to get here under the details, we're going to get everything that was in the page. Yes, you could get this through Fiddler, you could get it through Visual, the Dev Toolbar in Internet Explorer, but it's not as cool as getting it here. And it will tell me everything that was in the page, how long it took to load, and the response time for all the scripts and graphics and so forth. So a lot of times we already have this rig built at most clients. It's an easy way to hit a page, take a look at it, where am I getting hit, and where's my performance? So you can go back to your dev and say, what is this 300K JavaScript you're running on this page? Oh, it's some jQuery that overrides and hides the recycle bin basket. So tell them to go back and try again. Get around 20K, and then we'll load it on my server. Let's load another web test. It's for fun. Let's go down. We'll add a, now that I know it's on where it's at, I'm going to run another web performance test. Go away, shoo. Except for this time, we're going to go, let's do a search. We don't have a lot of time today, so I will do portal.com. So here's my search center. So I'm going to do a record. Let's say that we run into, I usually run something like Batman. Nah, let's run SharePoint for fun. Nah, I like Batman. I'm going to run Batman. So it's going to record everything and get my output. I'm going to go ahead and stop. It's going to write the script out. I use this actually all the time to test queries in search farms. This is a really fast, quick way to test searches. Anybody have over 1 million items in their index? Yeah, I mean, as soon as you have to crawl file shares, because, I mean, whoever cleans up their file shares? Nobody, right? I mean, like 1 in 1,000 companies have ever cleaned up their file shares. We see stuff from 1988, right? So once we get in here to our, well, let that run for a second. So once this is done, we want to come in here and look at the search results. We'll look at our query string parameters. And right here you say K equals Batman. So something you can do here. Now, can I just run this test over and over and over again and get a valid result? No, because Batman's cached. What we want to do is every time it comes up and runs a search, we want to feed it a new term. I'm not really a developer. I used to be, but I haven't coded in a long time. So the way I do it is this. The way I do it is come down here into this value. See where I'm at down here in the bottom right-hand corner? And what I'm going to do is add a data source. Guys, we do this with forms-based authentication too. You want to run through 100 users, create a table with their name and password. Not hard. And what I'll do is add a data source, and I'm just going to use a CSV file for simplicity. I suppose you could use a database if you were DBA and you really think that's cool. What I've done is create a word list. I just went out to the internet and created a word list. You could create one off of your 2010 index that was valid words in your company. It would get a little more valid result. And all I'm going to do is wire this up, copy it into the project. So now when I run, oh, there's a glitch in this. See the glitch? K equals what? This is where it says, did speaker encourage user participation? You actually have to open this back up again. See this after I do this? And actually choose the first letter, and then it will actually now change the script. So one little bug just to think about, not a huge deal. Now if I run web test, I'll just run this test, and we'll take a look at the details. That is awesome. Code violation 403 forbidden. I have no idea why I did that. And we're seeing request time 3:34. Secured browser. Well, I can change that. So now every time we run a search, we're actually going to feed in a new word, inject a new word every time. I only have 500 words in that demonstration. Well, let's do more than that. What if we want to now test? We have 4 web servers with 8 gig of RAM, 4 web servers with 16 gig of RAM, and we want to move where query and web and stuff is around on our farm, and we want to get some reporting. So we want to know what's the best way and do some compare. This is the favorite part of the product that I like, because what I'm going to do is come over here to load test with me, manage controllers. The controller should probably be a proper server, if at all possible. One of the mistakes we see is there's not enough testing hardware. You have 4 web front ends with 12 gig of RAM, 64-bit, 4 core, and you've got this on a laptop trying to create traffic. Right? This laptop can't create enough traffic to put the stress on those servers need. So here's where we see our result store. This is actually where we're going to store our SQL database, whereas we can now take all this test information and feed it into a SQL database. We're going to do that on our SQL server, and it is actually really cool. We made this easy as well. So over on my SQL server, I'm going to open up SQL Server Management Studio. I've gotten to where I love 2012 server. Hit the Windows key and type whatever I want. It's magic. It just works. Let me connect here. And we need to create a database. So we're just going to say File, Open, File. Now, it's actually going to be, though, on the box. OK, you with me? On the client where you have Visual Studio loaded. So here I had it on Visual Studio is on FE01, $. Microsoft Visual Studio. And it should be load test repository.sql. See that? This is cool because this saves us a ton of time. And all I have to do is open that. Should be fairly quick. Look at that. And we're just going to execute it. And what that's going to do now is create a database that's already ready to host all the information from Visual Studio Performance Testing. Cool, huh? Looks like that's done. So let's go back over to our Visual Studio. We're going to put our server name is app01, refresh. I should have used Windows authentication. You guys were supposed to catch that for me. And then we collected that. We need to create a database. And right there you see it's called load test 2010. My script still says 2010 in, and I guess I should change that to like 2013. And then we could test a connection, for example, it succeeded. So what we've now done is we've wired up a database with Visual Studio. So now as we run tests, more of these tests, we can now go back and do reporting. There's a Codeplex project that'll allow you to run reporting services based on this data. So it'll let you slice and dice it in the web browser at a later date. Now, one of the things I'm not going to do today because of time constraints, we can actually add agents here. We talked about making sure we had enough testing hardware. So if I've got a large web server farm that I need to test, I probably need 3 or 4 or 5 machines generating packets and throwing at the server. One of the things we can do here is load an agent on Windows 7 boxes, Vista boxes, or higher. So we can just use like engineers' workstations after they leave for the day, turn the agent on, and use those to generate traffic. I highly suggest not doing this on your production environment in the middle of the day, because you probably will create a denial of service on your servers, and you start testing this. So what we'll do here, I'll go ahead and close this. We've wired up the database. So the next thing we want to do is we're now going to come in and add another test. Come in. Except for this time, we're actually going to run a load test and not a web performance test. Now, you could have lots and lots of web performance tests, maybe one for your HR page, one for your customer employee onboarding. So you could have lots and lots of different web tests, but we're going to create a load test. And we're going to call this Monday morning. Let's say that Monday morning, most people come into the portal homepage, and that is where their browser defaults to. And let's do a think time of 1 second between test iterations. You can actually use recorded think times too. So you could have a scenario on SharePoint where you go through and you click and you go through and you click another button. Maybe it's an InfoPath form somebody's filling out. They fill it out in form and click OK. It will actually capture, the recorder will capture all the timing of that. And then when you replay it back, you can say use those think times. Otherwise, I'm not sure how much credit we give users for thinking. All I know is that users, if the page doesn't come up immediately, they hit refresh. You ever notice that? If the page still doesn't come up, what do they do? Hit refresh again and refresh again. I don't know what they think. Like it transmits kinetic energy into a battery that we then transfer back into the servers to get green. I don't know, but. So one of the things I like to do is what we call a step load. And what I'm going to do is start this at 10 users, 30 seconds for each duration. I'm going to go 50 users and maximum of 250. So here's what we're going to do. We're going to start out at 10 users. Now, real world, you want to run this for like 10 minutes, 15 minutes at a shot. Run this at probably, start at 10 users, run it for 50 minutes, then increase to 20 users, increase to 30, 40, 50, 60, and upwards. So if you can do this over a day or two, it's going to give us better metrics, and I'll show you why on the next screen. This is create a stair-step effect is what we're doing here. So because we don't have a lot of time, we're going to add 50 users every 30 seconds. Now, we talked about our web test, and this is where if we had lots of different web tests, so all the different things you do in your SharePoint environment, if you created one little web test for your HR portal, one for your BI, one for your sales, one for your customer onboarding, and we had all of these web tests listed, we can now come in here and create, mix and match, and create profiles based on the actual traffic of our SharePoint server. From here, I have created web test 1, 2, and 3, which is just fabulously named. And this is what gets better. I can now actually say this is portal read. That's probably 90% of my traffic. And we can now change the distribution or the mix and pattern of the traffic we're going to test with. And I still haven't written any code, right? So for us IT pros, this is a brilliant way for us to create a load test. And it gets even better. Now, worst case scenario is LAN. That means everybody's in LAN and they're hitting the server as fast as they can. What if we had custom applications that didn't tolerate latency well? I could now come down and choose a 3G connection or an intercontinental WAN or a dial-up, really? Dial-up modem? Ugh. But maybe somebody still has that. Second, browser type. You'll see that we have Safari for iPhone, Safari 3, lots of different options. Do all browsers behave the same performance-wise? No, they don't. We use this also with large companies when we are moving from, say, Internet Explorer 7 to 8. You can actually run a test and see how the servers are going to perform against the new browser type. Or what if this is a public-facing SharePoint site and you want to test across multiple? So we could do this, right? We could add IE9. Let's add, we have a bunch of iPhones, let's say. And let's say that we have some Windows phones as well. But let's say Internet Explorer 9 is the bulk of our traffic. And then let's say iPhones are like 3%. See what we're doing here? We're distributing what we believe to be our. Now here's the money part. I'm going to come in and add my servers. So it's important, though. From wherever the box that you're typing this on, you've got to have remote registry access to the servers. So those of you who are hosted or cloud, that could become an issue for you. You may need an actual box in the cloud to make the connection, RDP into it. This is my SQL box, so I'm going to check SQL. It's a preset group of counters for SQL Server. Then I'm going to add my app server, which is app02. It's an application server, so I'm just going to say, hey, application. I'm going to come in and add FE01, and it is IIS server, and we'll go ahead and grab .NET and ASP.NET. So here's what we're doing. We're going to add these 3 servers into our load performance test. Why do we want these 3 servers in our performance test? Because what we're going to do is we're going to go out, and the default is way too low, by the way. We're going to go out every 5 seconds and grab the counters. How much memory are you using? What's your disk? What's your physical disk queue length? What's your average disk queue length? 5 seconds is too much because the very act of you saying every 5 seconds is going to skew your results. Because you're asking it, you're overwhelming the server with testing to actually get good test results. This is why what we really like to do is set this at like 30 or 60 seconds. Every 30 or 60 seconds, go grab that counter and leave that each step of that stair step out at like 30 minutes. That's why I say that if we can stretch out the length of time we have at each stair step, we can change how the sampling rate up to like 30 or 60 seconds and get more accurate results. For the demo today, I'm going to use 15 seconds. I would recommend this the absolute minimum. From real world experience, 15 seconds, the absolute minimum to use for sampling. We don't need to warm up. We're just going to say 10 minutes, and let's just run this thing. So this is going to come out here. It's going to create a load test for us. We could now just run this load test, and it's going to dump all the results into the database, and it's going to come back on the screen with a really easy copy and paste Word type format. However, we have some custom applications written, and so what we want to do, we want to create a new custom counter set. This is really cool. And we're going to call this, custom widget, let's say. And then now what I'm going to do is come in and add counters. Now, if you already have your application installed, it's reading the registry real time off of this box. So as I change my computer here to some other box, it's going to show me all of the available counters that box has. So I could now track any performance counter on that box. You know, we install a lot of third-party products. When you install, they'll actually put their own counters in, like Nintex, for example. Those would now show up in here, and as I'm running my performance test, I could actually now get metrics off of those as well. So kind of cool. What I'll do here is select counters from the list. Let's do this. Let's just grab something. I don't know. See all my service apps, access services? Have you guys seen this before? Did you know these all existed? Easy money. You can actually just open up any server. Here, guys, watch this. Type perfmon. With me, just type perfmon. Come in here. Any SharePoint server in your farm. And let's say that I've got something really slow going on, and I suspect that my hosting provider has oversold my disk. By the way, they oversell disk I/O all the time. It's terrible. It's like cell phone companies. Oh, we guarantee, yeah, whatever, you're lying to me. And one of the ways we catch them on lying to us is we go to physical disk on our virtual machine, and we want to take a look at average disk queue length. And I'll go ahead and grab all the instances. Oh, okay. Let's find out what that queue length is. It should be 2, 3, 4, somewhere in there. If it's like 20 or 30, you've got no I/O. That means they've overloaded the I/O on that host controller, that host machine, on that motherboard itself, the bus. It's a really good telltale sign. The other one is if you're leaking packets. If you're leaking packets or your disk queue length is real high, go talk to your provider and say, no, actually, I've got some info for you that looks like you are undersold me. So we're going to go ahead and do this. So by the way, it's perfmon. You don't even need what I'm showing you here. But I could come in here. Let's go grab physical disk queue length, physical disk, and what I'll do is select counters from list. Let's go with current disk queue length. And so we now have we've created a new counter set, and you could have lots of different counters in this. Now, here's what's cool. Now, when I go back into this, look what shows up as another option under each server. My custom counter set. So now I could come back in, and now on this FE01, where my custom code lives, I can now be monitoring that custom widget during my load test. Well, because we're running out of time, now what I actually have to do is run this thing. And I'm just going to run a load test. The first thing it's going to do is crank it up. In the top, it's going to open up some UI. You'll see by default it opens up these 4 graphs, which are basically unreadable. I don't like them. I'll tell you a tip. What I like to do, the first thing, is I like to change these to a single panel. And what I want to do is start seeing my graph. So here's what we're looking for. I'm adding users, and as it steps up, I should be seeing my CPU step up and my memory step up. And then we're going to see it start breaking, getting red flags, and I can now take a look at the number of users and know exactly where I'm breaking my servers. I'm on a little bitty laptop. That's my testing machine, my application machine, my SQL machine, 2 web front ends. So I'm going to get a red thing pretty early. So let's take a look and see what happened here. It's probably CLR runtime. It almost always is first. Note, processor was overused. So you can see here that percent processor time flagged us even at only 10 users. But on your big servers, you won't see that yet. Well, you hope you wouldn't. You might. I mean, it could happen. Usually what you see, do you know what the average server tanks at, I see, by the way? 12 gigabyte server, 4-core, 64-bit, around 50 to 60 simultaneous users is done. That's it. That's all you get pretty much by default, concurrent. To go beyond that, you got to start doing caching. You actually have to start engineering. So what you now are looking at here is a graph, and I love the graph because it shows you this isn't as pretty as what you would get at your home, right? But what this is going to show you is here's my user load, here's my pages a second. I can track my time on pages per second, my average page per second, and it'll show you exactly the counters that are breaking at every given point in time. Is this cool, or am I just geeky? I think this is cool, because you look like a rock star, because we spent less than an hour and we built one in this environment. Because they're going to say, well, we just spent 100,000 pounds on Load Runner. Get your money back. I'll show you how to do it for free. I mean, for most of what we're doing in SharePoint, we don't need that 100,000 pound tool. or that 30,000-pound tool? Most of what we need is, will it take 200 users or will it take 2 users? That's what I need to know, right? I don't need to know exactly what it will take. So the thing's going to run for 7 minutes and 31 more seconds. At the end, it comes out and spits out a really nice, maybe I can just stop it here. You can say I have 35 threshold. It's writing results to repository. It's writing off to that database. Kind of cool there. We can go back and look at it again. And you can also access, really cool, guys. I'm going to run out of time for this. But you can actually down here go access past tests directly from the database from Visual Studio. So I can open up those tests and look at the graphs and metrics from them. And this is just a stupid pet trick. You can copy and paste this into Word really easily right now, and that's one of the easiest ways to get a real report fast. Without running some report tool or Codeplex project, you can just copy paste. So here's what we're looking at. We're now seeing 20.2 seconds average on each of these pages, and you could see your distribution in your environment. So all done with Visual Studio. I wrote no code, and can tell you I'm pretty sure I know in your environment, if we came in and did this for you, how well your environment's going to behave. So questions? Yes?
Given that most of the 2013 UI, especially a lot of the web parts, run JavaScript, particularly asynchronous, they don't get picked up by the web performance test, do they?
The client side will not know.
So how would you go about simulating that in a late test if they're running client object model queries, executing additional queries?
You would have to have something on the client itself. I wouldn't promise you the agent might actually be able to do that.
But yeah, you'd have to simulate.
That'd be a good question. I would ask a developer. Was who I would ask. It's a really good. I've never been asked that before, but you are right. CSOM, you talk about CSOM, JSOM. Somebody else asks a question I can answer. It will do Ajax and all that good stuff. So it will do most of the other cool stuff. But as we go client side, yeah, I don't know. It's a great question. Okay. Well, you can see this is running. I am going to wrap it up. So if I have any more questions, thank you very much. In here in 15 minutes will be the experts panel where all the speakers are going to be in here, and you can see if you can stump the chump. All right? Thank you, guys. Very attentive.